Hello everyone, welcome to this tutorial by Zebra Code. In this tutorial, we are going to look at the iomanip library in C++. But what is it? The iomanip header provides mechanisms to change the output style of a program. It is very useful for data presentation and visualization on the screen. The iomanip library allows us to do a set of basic input-output manipulations with the cout object in C++. But what exactly is iomanip? Well, the iomanip stands for input-output manipulator. It is used to format data on the screen which is printed out with the C++ cout object. It needs to be included as a header file for us to be able to use it. And all functions in the iomanip header files are in the standard namespace. In other words, you could use the standard std : prefix for functions, or simply add the using namespace std as a part of the program. The iomanip function applies to the data that immediately follows it. That is, in terms of application, the data that immediately follows it is what the iomanip function will be applied to. More iomanip functions are available in later versions of C++, e.g. C++ 11. There are some of the functions that are useful in this version or later version, but they are not really useful, or they are not implemented in older versions of C++. Using the iomanip for spacing, the iomanip library has several functions that we can use to space out, format, align text, present data or information nicely on the screen. There are so many functions in the iomanip library. Some of them are listed out here. The compiler will implement them for you if you are using any version of the C++ programming language. However, the ones here highlighted in green are only available from C++ 11. I mean the get time function, put time function, get money, and put money functions. If you are using C++ 11 or later, you will be able to implement these functions in your application. Here is an example of how to use the set width to align text on the screen. The cout C++ object will print the zebra code string on the screen. Normally, the feed width for zebra code contains 9 boxes or 9 characters. When we use the cout set width 18 zebra code, now we will be adding extra 9 characters to the 9 characters that zebra code contains. So the feed width for zebra code 9 boxes with extra 9 boxes to the left. Altogether, we have 18 boxes. 9 boxes for empty symbols and 9 boxes for 9 characters that are in the text. What that means is the text will be aligned to the right, but before the text is printed out on the screen, 9 extra boxes will first of all be printed, and there won't be any character inside those boxes. They will just be blank spaces. Now, using the setfill and setwidth function for fields, we can also use this one for text alignment. Look at this example here on the screen. Cout setfill, and the dollar symbol, setwidth 12, then the number 101. What does that mean actually? Setfill will fill the empty boxes with this character, this symbol, $sign. Please note that it's in single quotes, not double quotes. Then setwidth, we set 12 spaces for the text, and we actually have only 3 text here, or only 3 characters. So the remaining 9 will be filled with this symbol that setfill is assigned. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the digits 101 will be printed in the remaining 3 fields. And the result for this statement will be this, as $9 symbols, then 101. This is how you use the set fill and set weight in the iomanip library in C++. Now, using the iomanip set precision function, this is a program that is fully implemented in C++ using the iomanip header file. There is a variable of data type double, and we name the variable cost. The value assigned to it is 3.662367. Now we are going to use the set precision to print out this cost to the screen. So if we say cout set precision 3, that will print out 3.662. What that means is easy to understand. After the decimal point, 3 characters will be printed because we set precision to 3 characters, and that makes it to be 662. Then the second one is set precision 4. So 4 characters will be printed after the decimal point. Set precision 5 makes it print 5 digits after the decimal points, while set precision 6 make it to print out 6 digits after the decimal points, 1, 2, 3, 4, 5, 6. Then set precision 10 allows it to print out all the characters after the decimal point, as well as extra 4 zeros, because we set it to 10, and if you count it here, that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes this depends on the compiler version that you are using, because when I tested this code on 2 different versions, the results were slightly different. So in your case, it might be exactly this or a bit slightly different. However, the concept remains the same. Now, formatting manipulators and their effects using set weight, set precision, and feast. Let's quickly go through this and see how they are displayed on the screen. The manipulator values display observations. If we say set weight 2 and we enter the value 8, it will be printed this way. Mind you, these vertical bars are just here for illustrations. So there will be 1 space, then 8. That means it has 2 boxes. Value fits right in the field. Now set width 52, it's obvious here the value fits right in the field. But set weight 2, now we are entering a value of 255. It will still fit in, but now field width is ignored just for this data to be displayed. It's a whole number, it's an integer, so everything is still displayed. With this one here, set width 8.5, everything also fits into the field width. Here, set width 5, feast, then set precision 2, and we are entering a value of 4.225. Here you can see that it shows 4.23. What is happening here is easy to understand. This number 5 is rounded up, making it to print 4.23. The field width is set to 5 and 2 decimal places expected, last digit rounded up because of these 2. With this one here, set weight 5, feast, set precision 2, and we are entering a value of 35.7, so it is printing out 35.70. The reason for that is easy to understand. Set precision is 2 and it is automatically adding extra 0 to it. So value fits right in the field, however an extra 0 is added to the decimal point. With this one here, set width 5, feast, set precision 2, and the value 228.542 is entered. The value fits into it. The 2 decimal values fraction digits display while the field width is ignored. So because it's 2 here, you can see here is 54, so the other 2 is cut off. Now set width 5, feast, set precision 2. Here we have a value of 228.547, so 228.55 is printed. What happens here is easy to understand. 5 is displayed because 7 is rounded up and 4 becomes 5. That is why we are having 0.55 here. With this one, set width 5, feast, set precision 2, 888, everything fits in here. Everything is printed out. Nothing is rounded up here. So the set width, fixed, and set precision number can also cause scientific notations to be used for values. Sometimes this depends on the compiler version. You would definitely need to know about the concept of the iomanip library if you are going to be doing mathematical, statistical, engineering, data analysis, or scientific work in C++. In a nutshell, you really need to know about it as a C++ programmer. Now, with that said, let's look at some practical examples of iomanip and its functions in C++. Alright, now let's write some code in C++ and make use of the iomanip library. I have created a file here and I named it shares.cpp. It is saved in a folder which I named Zebra Code. You can use any text editor of your choice to do this task. Now I am going to add a few header files that we will be using. Include io string, include string, include iomanip. Then we will also include the cmath library because we will be making use of some functions in that library. So these are the header files that we will be using namespace, standard, int main, return 0. This is our standard file structure. The iomanip header file. So now let's write our first example. Example 1, printing strings with the set function. Setw stands for set width, cout, Zebra Code, end line. Now let's save, compile, and run it. Great, it was compiled successfully. Now let's run it. Great. Now it says here Zebra Code, and if you look at it on the left hand side, we have got 9 extra boxes, which is a block of space, and on the right hand side we have Zebra Code printed out on the screen. So this is a result of the set width 18 Zebra Code that we wrote in our code. That was fine. Now let's do another example. We'll call this example 2 using set precision, cout, as a vertical bar, set width 12, fixed, set precision 4, 29, 95, another vertical bar, end line. Now let's save and compile and run our code again. Great, it was compiled successfully. Now let's run it. Great. If you look at it here now, it has added 2 extra zeros to it. The reason for that is because we set the set precision to 4, after the decimal place, it added extra 2 digits to it so that it will all be 4 digits. So we have the space in here because we set width. So this is how you use the set precision in the iomanip library. Let's do another example. I'll call this example 3. Setting width and doing right and left text justification. So let's do that. See out. I'll put a vertical bar there again. Set width 22. Left 2000. Another vertical bar. End line. Okay. I'm going to do the same thing here. See out. Vertical bar. Set width. Also 22. This time right. 2000. And another vertical bar. End line. Let's save, compile, and run our code. Great, it was compiled successfully. Now let's run it. Great. Now if you look at it, 2000, this one is left aligned with the extra blank spaces, and this one is right aligned with the extra blank spaces to the left. The blank space is here to the right, but the blank space is here to the left. This is how you use the set width and set precision with the fixed and right and left alignment in the iomanip library. Now let's do another example. I will call this example 4. Using the setiosflags. See out. Vertical bar again. Set width will be 10. Set ios flags. ios colon right 1900 vertical bar end line. Now I am going to copy this line and paste it right below this one 3 times. This when we should have it. Okay, now I have it 3 times. I'm going to change the values here. That will be 2000 and this one will be 3000. Everything else stays the same. Okay, I have these 3 lines here now with these set ios flags, and everything is going to be right aligned. Let's save and run our code. Run shares. Great, everything was run successfully, and now you see 1900, 2000 and 3000, they are all right aligned. So let's demonstrate it one more time by changing the right to left. Now let's save it. Okay, now I'm going to comment this section out so that it doesn't get printed every time. Okay, now let's save, compile, and run our code again. Great, it was compiled successfully. Now let's run it. Exactly. Now if you look at it, it is left aligned, and we still have the blank spaces to the right of it. On this very one, it was right aligned and we had the blank spaces to the left. Now it is left aligned and we have the blank spaces to the right. This is how you use the setios flags in the iomanip library. Let's do another example. I will move this comment to the bottom so that this part of it doesn't get printed again. This time I will call it example 5. Formatting weight, set weight, left, right, and set precision. See out. Vertical bar here. Set weight, set it to 20, right, set precision 5, exponent 1 dot. That is the reason why we added the CMAT library, because we knew we were going to use some functions in that library. then a vertical bar again, and line. I can quickly copy this same line and paste it right below it for a few other functions. Change this one to log 18.697. This one will be log 10. 18.697. This one here we can use pi. So let's save it, compile and run it again. Great, it was compiled successfully. Now let's run it. Exactly. So this is the result, and everything here is right aligned. And because we set the precision here to 5, we are getting that result. So this is how you use set precision, set width right in the iomanip library. Now let's do another example. I will call this one example 6. But before then, I'm going to move this one again to the bottom of it so that everything there doesn't get printed. Example 6, displaying mathematical data with set weight. You see out, set weight will be 3, put 9 there, end line but no semicolon, set weight 3, I'll put 32 here, end line also no semicolon, set weight also 3, put 615 here, 615 also end line and no semicolon. Now new line. Now let's do the addition here. 9 plus 32 plus 615, end line, this time with a semicolon. So that ends the statement. So let's save our code, compile and run it once again. Great, that was compiled successfully. Now let's run it. Exactly. Now you see how it is displayed on the screen. Everything is aligned successfully and correctly. So the total is 656 when you add all these things together. But look at the way it is displayed. This is how you use the set width to display data with the iomanip library in C++. Let's do one other example because we can actually ask the users to enter data on their own and we display it this way. Let's do that. I need to move this one down again so that it doesn't get printed next time we try to run the code. Example 6a, displaying mathematical data with set width interactively. Let's do that. First, I will create some variables, int a, b, c. C out. Enter 3 digits between 1 and 100. End line. C in A, B, and C. Let me move this one up a bit. Okay. C out. Set width 3. A, end line, set weight, so 3, B, end line, no semicolon here, remove that, set width, so 3, C, end line, new line, Now let's do the addition. A plus B plus C. End line. Now with a semicolon. This is basically the same code as this one here. I just decided to type it up once again. Now let's save and compile and run our code. Great, it was compiled successfully. Now let's run it. Great, it was run successfully. Now it says enter 3 digits between 1 and 100. I'm going to enter 6. I'll enter again 89. Now I'll enter 87. Exactly, so it was displayed successfully and correctly. 6, 89 and 87 added together, we get 182. So this is another way of displaying mathematical data with the setweight function in the iomanip library using an interactive form. So now let's do another example. I'm going to move this one to the bottom again so that it doesn't get printed every time. Now I will call it example 7. Example 7 using the setfill function in the iomanip library. Cout setfill, the dollar symbol here. Don't use the double quotation marks here, just use the single quotation marks. Okay, cout setfill, this is the dollar symbol we are going to print out, then set width 12 and the value is 101, end line. Now let's save, compile and run our code. Great, it was compiled successfully. Now let's run it. Great, see now we have 1 2 3 4 5 6 7 8 9 dollar symbols, 10 11 12 and 101 added to it, it becomes 12. So we have 12 characters here printed out. The first 9 are the dollar symbols which we fill it with, and the other 3 101 are the digits that we actually entered here, which is 101. So that is how you use the setfill function in the iomanip library in C++. Now let's do another example. I'll call it example 8. Before then, let's move this comment to the bottom so that it doesn't get printed every time. Using setprecision with double digits. I'll first of all create a variable here of data type double. I'll call it cost equals 3.662 367 semicolon. So we have a variable here of data type double. The variable is cost and we have assigned it this value. Cout setprecision 3 cost end line. I'm going to copy this line, paste it below it several times. So this one here, I'll change this to 4 5 6 and this one 10. Now let's save, compile and run our code. Great, it was compiled successfully. Now let's run it. Exactly. Now look at the display here, 2 digits, 3 digits, 4 digits. This one is 5 digits, but it has been rounded up here, while this one has all the digits displayed. So this is how you use the set precision for multiple digits in the iomanip library. Now let's do another example, and I will call it example 9. But before then, let's move this one to the bottom. Okay, for example 9, I have a program that shows grouping of bits and bytes in a computer. I typed it up already. Now I'm going to compile it and run it to show how we can use setw to format data display with the iomanip library. Let's compile it. Great, it was compiled successfully. Now let's run it. Exactly. And you can see the result, how it's being displayed. Everything was displayed nicely and it was also well formatted. Once again, note you can also use 1000 bytes etc instead of using 1024 bytes to do your calculation. So let's do another example. Before then, I'm going to move this one to the bottom again so that everything doesn't get printed out each time we run it. I'll call this one example 10. Now our next example is example 10, showing the size of data types with the setw function. I have typed this up already and I just pasted it here now. So I use the setw in the iomanip library. Let's compile it and run it. Great, it was compiled successfully. Now let's run it. Great, it was run successfully. Size of int 4, size of double 8, size of float 4, size of decimal 4, size of string 32, size of char 1, and size of boolean 1. So this is how you use the setw to display data in the iomanip library with C++. Let's do one more example, and before then I'm going to quickly move this one to the bottom again so that everything doesn't get printed each time we run the code. I'll call this one example 11. So example 11, working with the put money function in the iomanip library. It's been available since C++ 11. It will round up the number if the decimal value is over 50. So let's do that. I'll first of all create a variable of data type double. Now we also name it cost, and let's assign it a value 989.58. See out. The amount is put money, put cost, end line. Now let's save, compile and run it. Great, it was compiled successfully. Now let's run it. Exactly, the amount is 990. What happens here is this: the amount here is 989.58. So 58 is rounded up to 1, then added to this, it becomes 990. For example, if I change this one out to say 18, let's save it, compile it and run it once again. Great, it was compiled successfully. Now let's run it. Exactly, now it's 989. What happens here is that the fraction 18 is less than 50, so it was not rounded up, it was just left out. So it printed the whole number 989. This is how you use the put money function in the iomanip library in C++. This has been available since C++ 11. Now let's do the final example, which is about shares. I'm going to move this one to the bottom so that it doesn't get printed each time we run the program. I'll call this one example 12. Example 12, stock market and shares display with iomanip. This is a long piece of code. I have already typed it up. I'm going to copy and paste it here, then explain it. Save it. So what we have here, it's a piece of code that shows the names of different companies, and we are going to show their share values as of November 5th, 2021. This was the result of the stock market as at November 5th, 2021. So we are using the set weight, set precision, and feast to display the results of the stock market. So let's save it, compile, and run it. Great, it was compiled successfully. Now let's run it. Exactly. Now if you look at the result here, it says companies share values, stock markets. It's for November 5th, 2021. This was the previous day or the previous report. Then this is the change. So S&P 500, this was their stock market, so on. So if you see how everything is displayed here now with the right decimal places, it was made possible with the iomanip library. This is how you use the iomanip library to display data neatly on the screen. This code is very long. There is nothing dynamic in it. It was all typed in statically. So I will make the code available in the description section for this video, and I will also make it available on GitHub. Thank you for watching this video. If you think you have learned something from it, please subscribe to our channel, comment on the comment section, and share the video. Bye for now.